Today we're going to talk about the Qualcomm Snapdragon X Elite and X Plus, the two chips that should have Intel, maybe, running scared. Hi everyone, it's Mark Hochman here from PC World, and I'm here with Kedar Kondap, the Senior Vice President and General Manager for the Computer and Gaming Division at Qualcomm. Hello, thank you for being here.
Thanks, Mark. Thanks for having me here.
Absolutely. So today we are going to talk about the Snapdragon X Elite. What I wanted to do was first just start out with talking about at least just the terminology. So we've talked about Snapdragon X, Snapdragon X Elite, Orion. Can you just tell us what those terms mean, first of all?
Sure. Thanks again, Mark.
Sure.
Thanks for having me here.
Mm-hmm.
I think maybe just to characterize what all of these different terms mean, Snapdragon X Elite is our premium platform for notebooks. The X Plus is a new platform that we're introducing now with the aim of being able to expand this portfolio and make all of the goodness that we have with Snapdragon available to more users. And more specifically to your question on Orion, Qualcomm Orion is the CPU core that is used in both the Snapdragon X Elite as well as the Snapdragon X Plus platforms.
So is it fair to say that Snapdragon X Elite is the premium solution and the Snapdragon X Plus is more value?
I'd say high end.
High end, okay.
More high end,
All right,
definitely.
Fine. You know, when we talk about ARM, historically, you know, we've had this sort of big little architecture where we've had performance cores and we've had efficiency cores. The performance cores being devoted to high-end, intensive workloads, efficiency being done for background work and so forth. You guys haven't taken that approach with the Snapdragon X Elite. Why not?
You know, Mark, we look at the architecture every time we come up with a new platform. Mm-hmm. And just to put things in perspective, the Qualcomm Orion CPU is a custom CPU that we've designed in-house. Mm-hmm. It's a ground-up design for us. And we're very confident of being able to deliver, as you saw some of the numbers, with respect to performance as well as the power, to be able to deliver the right experience when it comes to battery life, and at the end of the day, make sure that we maintain a performance per watt leadership in market. Mm-hmm. So we have all of the tools necessary. We have all the software algorithms to be able to more effectively manage all of the symmetric cores, if you will, and provide the necessary battery life that we are hoping to provide to our consumers.
Mm-hmm. Well, I mean, you certainly can't argue with the performance numbers. Battery life, give us a ballpark what we should expect in terms of battery life. I know it's dependent upon a number of factors, but you know.
Just depends. Like if you look at some use cases, for example, let's take a very common use case that we're all used to, which is video calls, say a Teams call, and let's say it's a 3x3
sure.
Teams call. You should expect up to 2x. Right?
Okay.
So
2x what?
2x battery life.
Okay, versus?
2x versus competition.
Got it.
Versus an x86 competitor.
Sure.
And so it just depends on if you look at YouTube, if you look at browsing, or if you look at any of these use cases. The numbers can vary, but like I said, yeah, it's more than 50% in some cases, and it just varies depending on the use case. But very impressive experiences that consumers will be able to see with this, with both the Elite and the Plus.
Mm-hmm. Well, historically, when we've talked about the earlier Qualcomm Snapdragon chips, I'm thinking about the 8 series, the 8.6, sure. and so forth. We've talked about, and again, it depends upon the OEM, it depends upon the size of the battery and so forth, the workloads. But we've talked, I think of those machines, those historical machines, as 12, 16, maybe close to 24 hours of battery life. Is that's the ballpark, or at least maybe even the baseline
for sure is the baseline.
Okay.
I think as what's going to change now and what's going to get even more fun is the next gen AI experiences that are going to be driven off of these platforms. So
we'll talk about that in a second.
Yeah. Mm-hmm. So I think it's just going to get. I think it's fair to assume that is a baseline. We come from that legacy with respect to making sure that power is top of mind for us when we design the architecture of all of these platforms. So yeah, I think it's fair to assume you should expect some pretty incredible battery life numbers.
Excellent. Well, I wanted to just make sure that we point out I guess we call it the elephant in the room. I don't know. This is a Qualcomm Snapdragon X Elite reference design. You guys have been using those, dogfooding those for months now. Is that right?
Yeah, we're all using them internally. This is
right.
One of my machines as well. We use them every day as our workhorse machines internally.
And one of the things I think that I was impressed by as well, and that we found this information out even before we had access to the benchmark data, was the fact that you guys have I mean, a number of PC makers backing this, and it wasn't like, historically it was always Lenovo, HP would contribute and so forth. I mean, just to reiterate the names that you guys were talking about before, Acer, Asus, Dell, HP, Lenovo, the Microsoft Surface brands, Samsung, Xiaomi, and then Honor, who had never actually delivered a PC before, is getting into the laptop space. Yeah. So those guys are, I'm assuming, still on board. I mean, there's nothing changes.
We're pretty excited to be partnering with all the OEMs. I think you are. All of our people that are watching this beautiful show are going to be very excited with the devices that will come to market.
And these are coming to market in
mid-24.
Mid-24. Okay, great, excellent. You had talked, or I should say, Qualcomm had talked about 12 watt, 23 watt, and 45 watt, scalable to 80 watt. Let's talk just briefly about what those numbers mean, because I think most people are used to buying, or at least talking about, like U-series core chips, or H-series core chips, or P-series core chips. We talk about these things in the context of TDP. Can you give us a sense for, okay, I'm a reader, I'm a viewer, I'm looking to buy a Snapdragon X Elite laptop. What do those numbers mean?
Yeah,
can you explain?
Great question. Uh-huh. I think the numbers that you, just to put context on the numbers that you were talking about right now, that's the total thermal dissipated power for a particular laptop. Mm-hmm. And what that means is it just depends how fast you're able to run a particular platform. I think the beauty of Snapdragon X Elite as well as the Plus is that it's a very versatile platform in the sense that we have a single piece of silicon that can scale to all of these different thermal design points. What that means for a consumer is you could be someone that says, I'm just a normal user in the sense I don't use any high intensity application that necessarily stress the system out. I just want a thin and light, say a fanless design, and I just want it, so that would translate into getting a lower TDP type device. Or somebody could say, no, I'm one of those workhorse type users where I want to be able to run some intense applications, and I want to push the performance to as high as I can possibly get. So then you'd go with a device with a higher TDP, which means you have the ability to score a much higher benchmark numbers or get a higher performance out of the CPU. So that's exactly what it means. But then, like I said, the versatility of the silicon is that our OEM partners are able to use a single piece of silicon to scale all of these different TDPs, if you will, and without having the need to go multiple SKUs and variants and stuff.
And we're seeing a clamshell here, but I mean, you could put this in a tablet, I assume.
Yeah, you can put it in a tablet, you can put it in a 2-in-1. There's nothing limiting different form factors with this platform.
Okay. One question I wanted to make sure I asked, and we've got a little bit past that, but I just want to make sure that we understand. In terms of, okay, you've obviously signed up a number of OEMs. A consumer is going to weigh a Snapdragon X Elite PC versus something from AMD versus an Intel. What's the, and you've alluded to this before, but what's the real selling point of a Snapdragon X Elite PC? What do you guys do best? Is there some
great question. I think the first thing is we talk about game-changing performance, right? And that just means that you highlighted some of the numbers. It just means we have incredible performance for any of the applications that you're talking about. And that can get translated to a consumer in terms of how quickly the application opens, like latencies for that. It could be a measure of battery life in terms of I can watch a YouTube video for multiple hours. And so first is game-changing performance.
Okay.
Second is we talk about connectivity. You get the best-in-class connectivity, whether it's Wi-Fi 7, 5G, all of these experiences. And then third angle, which is driving is the new experiences, which includes things like AI and other experiences. There's a lot. We have a 45 TOPS NPU in this particular platform. In both the X Elite and the Plus, we have the same AI capabilities. And the reason why we chose to lead the industry with this is because we've been doing this for the last many years, right? Okay. This even our HC Gen 3, the older platforms, has 15 TOPS, for example. So we put in a lot of the focus on AI several years ago in trying to drive the industry because we saw that coming. So I think you should look at it as three vectors to summarize, like game-changing performance, great connectivity, as well as next-gen AI experiences.
Okay, actually, that's a good jumping off point. Let's talk a little bit about the AI. Where is the NPU, this local processing AI, where is that going to be most important? What apps?
Yeah, great question. I think, Mark, the way to think about AI is going to be that it's going to have multiple use cases across multiple industries.
Sure.
Right from whether, let's take an example of a manufacturing line.
Okay.
And you highlighted a couple of things, which is immediacy, privacy, security. If you have a Snapdragon-based device on a production line, the benefit is you're going to be able to process real-time data and find defects, be able to debug defects real time, and time to fix. Because this is all translated into productivity. The amount of time that your production line is down is just costing you a lot more money. So when you think of on-device AI processing, that's one use case where you think. Then if you just start to expand, whether it is, if you're an artist, for example, and you're creating music, we show some pretty cool demos where you can type a prompt in and create some beautiful music on the fly. And so if you're a creator, you're able to integrate a lot of these on-device type applications. But also to add, I think what we expect is that, yes, the industry will move towards on-device AI. There'll be more processing as more of these models start to become more and more pertinent, and they start getting quantized to be able to run on device.
Right.
It'll start to have more and more of an effect. But I think till that happens, and even out in the future, we do expect like there'll be on-device AI, there'll be some hybrid where it's going to run on device and in the cloud, and there'll be some models that are just too large and they will continue to run in the cloud. So I think we should expect that to happen. But with on-device AI and us leading the way, there's more and more ISVs that we've partnered with that are porting their applications to the NPU. And what that means is it translates into a lot of things that you said: immediacy, privacy, security, instant analytics. But at the same time, it gives you lower power. The fact that you can run on the NPU so effectively means you're going to have a lot better battery life with the device. So
yeah, and I think that's an important point. I mean, one of the things that you guys pointed out offline was the fact that you can run an LLM, an AI chatbot on a plane, for example. And if you're putting together a presentation for your sales conference or something of that sort, you don't have to do it all manually. You can have this local AI running on your PC, doing your PowerPoint for you.
Exactly.
And I think that's a real world case selling point that really makes a lot of sense.
Exactly.
And of course, you can do various things. You guys have worked with DaVinci, for example, with Resolve, and one of the demonstrations you're showing off was just basically just identifying an object as it moves through a video, and then modifying that on the fly using. And the difference is, I think, is that before GPU was used,
correct,
but now you're treating it with NPU. And how does that? Can you explain a little bit what the difference is and how that will work in the context?
Yeah, so it just depends on any and every application that we have.
Okay.
It just depends. So we provide a standard SDK, we provide standard APIs, we provide a neural framework for all of these app developers, where it's very easy for them to be able to go right to, for that application to be able to write to our silicon and be able to take standard interfaces and be able to optimize. So you brought up DaVinci Resolve. There's so many different applications. We've talked, Luminar Neo has an application we've shown in the past with super resolution. You can do it in a matter of seconds, right? You can take a low-res image and you super scale that to a much higher image, and you do it in a matter of seconds, and the processing is really fast. So it just depends on the complexity of the application. We can do a lot of creative things, and again, it depends what models they're using. Some, as you know, use Llama, and some use other different kind of models, and it's just easy for them to be able to work with Snapdragon, because we offer that standard layer, if you will, where it's easy for them to be able to port their applications with standard APIs and SDKs.
How important is developer relations here? Because Intel, for example, is talking a lot about how it's working with a lot of top 100 developers to make sure that those applications run best on its own NPU. It seems like you guys would be doing the same thing. Is that right?
Yeah, we have a very strong list of ISVs already that have ported their applications to our NPU. We've talked about Beethoven, we've talked about Audacity, like the list goes on and on. Uniphore was a great partner with us at Summit. So yeah, the application list is growing. And the beauty of Snapdragon X Elite as well as Plus is is the fact that we have such a versatile heterogeneous architecture that we can easily enable, depending on the application, different use cases to run on different cores. For example, even if you're in a video applications, we have a small little NPU that sits inside the audio block, for example, that can take advantage of saying the audio portion of this runs in a small little NPU, and you're not really waking up the system. Or we have this sensor island where things like presence detection. You walk by your PC detects that it's Mark and it wants to unlock the PC. It doesn't have to wake up the entire application process. So the versatility of how we're able to achieve what we're doing with all these ISVs and third-party developers is because we offer that flexibility with our heterogeneous architecture. So yeah, our list with ISVs is long. I think you'll see a lot of these applications on some of the devices that our OEMs will launch.
I think you mentioned one of the more impressive demos that you guys showed off was like working with OBS, where OBS, I believe, the video encoding was done on the GPU portion, but the translation, the speech to text, speech to text, and even translation was done on the NPU. Right,
yes.
And that's a nice conjunction of those two working together.
Yes.
One question, just to get a tad bit nerdy, in that it looks like, over time, historically, go back to the days of, say, the Pentium or some you've had a general purpose architecture, and then over time, people have identified particular tasks that they want to accelerate, so they build in specific logic to do that. Are we at that point at all with AI? Have you guys identified specific tasks or specific workloads that you can optimize for inside the NPU, or is that just not the case yet?
No, we are. We are. In general, though, your point is correct. That's where we've had general purpose processings, right? From whether it's the CPU, the GPU, or now in the case of NPU, where we are optimizing workloads to run more effectively on through the NPU pipeline. But also, just to add to one of the points that you had was even a camera, right? We have a dedicated camera ISP, which is integrated. So a lot of image quality and camera performance that you will see will be drastically better with the Snapdragon X Elite and Plus PCs, because this is where we have general purpose blocks. Another example to add is we have a dedicated video block, as well as a dedicated audio block. And that's what I mean, the versatility of the heterogeneous architecture, where you have fixed function blocks to be able to run various parts of a particular application. So you could be running the video on the video engine and the audio on the audio core, and then say noise cancellation within audio could be running on the little tiny NPU. So and this is where it starts to add up to deliver like this really low power experience to a consumer.
I don't want to forget about the Snapdragon X Plus, which is the new bit. We haven't talked about that before. Do you want to talk a little bit about how that differs from the Snapdragon X Elite, if you would?
Sure. So yeah, we're pretty excited about enabling the Snapdragon X Plus. Our goal, just to reiterate the intent, is to make sure that we are able to offer the same goodness that we had with X Elite to a more broader set of consumers. Just to highlight a couple of differences between the X Elite and the Plus. The X Elite has 12 cores, whereas the Plus has 10 of the same Qualcomm Orion CPU cores. The GPU runs at 3.8 teraflops, and the Snapdragon X Elite has the dual core boost. The X Plus does not have the dual core boost. So a few differences, I'd say, that are there. But I think the key notable point is that the AI, which is the NPU, has 45 TOPS on both the X Elite as well as the Plus, as well as the same 8-channel DDR, LPDDR5X. So the benefit is, as LLMs are becoming more and more DDR bound, we wanted to make sure that as experiences evolve, as there are more AI use cases that are going to play a prominent role with these next-gen PCs, we want to be able to offer consumers the same AI experiences across both the Elite and the Plus. So that's one area where we've tried to keep a constant in delivering the same experience.
Does it consume less power as well?
Absolutely. The Plus will consume less power, and the numbers will be staggering compared to competition. Again.
So it basically allows you to migrate up and down the performance chain. Is that fair to say?
That's fair to say.
Now, the one thing I did also want to talk about too is you have gaming in your title. Is the X Elite? Is the X Plus? Are these gaming PCs? And if not, and if so, just put it in perspective for me.
Yeah.
Yep.
I think obviously, every consumer loves playing games,
Right.
and every consumer now loves being a creator. So, which is why I'll address the creator version first, which is why we said we showcase DaVinci Resolve and stuff, very important applications if you're a creator.
Right.
And then when it comes to gaming, I think at Snapdragon Summit, I showed a bunch of games as a part of the keynote, and we continue to optimize games. We have a legacy. We have all of the relationships. So I think, it will run games, casual games, very effectively. There will be some AAA games that will also run effectively, but it's going to take time before we optimize every single AAA title. But I think consumers that are used to playing casual games will have a very good experience.
And let's talk about this a little bit too, because I think this is where we get into some of the things that have haunted the ARM platform before. When Windows on ARM has historically had some issues with performance, has had some issues with compatibility. You guys believe you've solved those, though, between your work and Microsoft's work. Is that fair?
Yeah, we're pretty excited. I think with the work that we've done with Microsoft, as you probably know, it started with us and Microsoft, where Satya had announced the Volterra platform with the previous, I think it was a couple years back at Build, where we made sure that there was access to dev boxes. Microsoft made sure that there was Visual Studio and other applications that were available for developers. We made sure there was the SDKs that we were providing to developers. And yeah, we've made a lot of progress. And I think we're pretty excited of where we are in terms of application ecosystem, whether it's emulated or native. We feel very good about where we sit with the applications.
Now, one of the things that I did when I reviewed the Surface Pro 9 5G, it had an ARM chip in it. It was your older, the older Snapdragon, which was co-designed with Microsoft. And I thought that particular tablet did a great job of basically enabling what Microsoft had intended for the tablet. Microsoft 365, Teams, Slack ran a little bit slowly. I gave it a pass. Other people felt differently. Other people felt like, you know what, we're at a point where I just want to run this laptop as a laptop. I don't want to have any caveats. I don't want to have to make any sacrifices. I just want everything to work. Would you say we're at that point now with the Snapdragon X Elite in this particular architecture?
I'll tell you, Mark, I'm using this PC right now, and I have not run into any of those issues. Okay. So we've definitely put in a lot of focus to make sure that for a lot of the consumers that we're targeting, the applications run. We've solved a lot of the issues when it comes to enterprise applications, and so we feel very good. Of course, to be fair, it's a 35-year legacy of applications that exist, so
sure.
I'm sure there will be some applications that I think will still need to get ported, but I think overall we're pretty excited about consumers as well as where we are headed with enterprise or commercial, as they call it.
Terrific. That's Snapdragon X Elite. That's the Snapdragon X Plus. Any closing thoughts?
I think we're pretty excited about disrupting this industry. I think we're looking forward to it. As we said at Summit, we really believe X Elite is performance reborn. So we're very excited about the game-changing performance. We're excited about the AI experiences that we're going to bring. So overall, I think with the addition now with the Plus family and being able to expand our horizons, I think we're very excited for the upcoming launch.
That's awesome. Great. So thank you, Kedar, for being here today. And we look forward to testing the Snapdragon X laptops when they ship this summer. So I guess we're going to have to allocate a week or two just for battery life testing alone.
Awesome. Thanks for having me, Mark.
Of course.
I appreciate it. Thank you.
So we'll have more on the Qualcomm Snapdragon X Elite processor and the Snapdragon X laptops when they begin shipping sometime in the middle of this year. So keep reading PCWorld.com and make sure you're subscribed right here on the PCWorld.com YouTube channel. Thanks for watching.